Hey everybody, and today's video will be over transformations of quadratics. So what you see in front of you is a pretty funny picture. It's a lady with glasses, and in the picture on the left she is smiling, meaning opening up, and in the picture on the right she is frowning or opening down. Quadratics make a special shape that looks like a U, and they can be either up or down depending on the leading coefficient. So we're going to talk more about that in just a little bit. So some vocabulary words that you need to know is the vertex form of the quadratic. So we have done the standard form. Standard form was ax squared plus bx plus c. Now we have a new form, the vertex form, which is a x minus h squared plus k. The reason it's called vertex form is because my vertex comes from the h and the k. In this equation, the vertex will be equal to h comma k. Now the parent function is x squared. Basically, every quadratic is derived from x squared. How does it change from x squared? Does it go up, down, left, right, flip upside down? What's happening to this quadratic? So in order to see what the parent graph looks like, we need to get out our calculator. So in your calculator, you'll actually see a table button. It's directly to the left of clear. So when you hit table, you're going to get a screen that says y equals, and then enter the function in terms of x. Now our function is simply x squared. So you're going to type x. This is the rare time that we can actually use x in our calculator, and then to the second power. So if you're looking for that x button, it's 2 buttons above on. And I would hit enter. Now you come to a new screen that says Start, Step, and Auto. It's asking, for what x value would you like me to start creating this table? I'll leave it at 0 for now, and then we definitely want to leave our step at 1. What that means is that from each point I go up 1 or down exactly 1. If you put a fraction, it'll go up and down a fraction. So if you say a fourth, it'll go from 0 to 1/4 to 1/2 to 3/4 to 1. We don't really need all of that, so I'm going to leave the step at 1. So keep hitting enter until you get to OK, and you'll see a table of values. Now you'll see that at 0, y is also 0. At 1, we get 1, and at 2, we have 4. Now if I scroll up, I'll notice that I have a -1, 1, a -2, 4, and a -3, 9. And I can scroll down and see that +3 does result in a 9 as well. So what that means for us is that we now need to plot these points. So 0, 0. Let me get my marker back out. 0, 0. Whoops. -1, 1. -2, 1, 2, 3, 4. Whoops. Let me get my eraser. That one doesn't belong there. Sorry guys, I'm a little bit off it seems. I'm going to erase this and start over. Alright, so there we go. We have the dots now. Sorry, it took me a little while to get that taken care of. Now what you need to do is you need to connect those dots to create a parabola function. Alright, so as you can see here, here's the parent function y equals x squared. Now things are going to happen to this graph. That's what we call transformations. Alright, so as you can see here, we have a little applet. This was created by Dr. Laval, who's a math professor over at Kennesaw State University. So we have here the parent function y equals x squared. And the way I know that is because I have 1a, my vertex is at 0, 0. So right now we have a parent function. And what I need to do is I want to see what happens when I change the number out front, my leading coefficient, what happens when I change h, and what happens when I change k. So let's change a, and what happens when we start, as a starts to increase, is that we become more narrow. Okay? Now if we revert back to 1, which was our original setting, okay, that was our original setting, now we can go fractions. And notice that as I get to a fraction, I get much, much wider. Now, if I hit 0, this is not going to be a quadratic function, so 0 is not allowed in this applet. But what happens when I have a negative a? Notice a negative a flips it upside down. Okay, so we have a negative number less than 1, makes it wider and upside down. Now, the minute I become negative 1 or negative 2, negative 3, I become upside down and more narrow. So it's a combination here. So let's slide this back up to positive 1 and see what h does. Okay, if I move to the right, notice that the graph is also moving to the right. If I add a negative number, I move to the left. Okay? Let's put that back at 0, 0. Now let's look at k. Add a positive number, I go up. Add a negative number, I go down. So these are the 3 important changes that we are going to talk about in our lesson for today. Alright, so as a refresher, if the number out front, my a, my leading coefficient, is positive, it will open up. If it is negative, it will open down. Now, if we know that a is greater than 1, it becomes more narrow. And if a is between 0 and 1, it is wider than normal. Alright, so remember that a positive quadratic opens up and a negative quadratic opens down. I always remember this, like if you're a negative person, you seem to frown more, and a positive person smiles more. Now also, we need to be careful about h. It says if h is positive, it shifts right, but if h is negative, it shifts left. We have to be careful because in the equation there is a negative sign in front of my h. So if you look at this, x minus 5, this actually looks like it would shift to the left. The problem here is that the negative belongs to the equation. This is actually a positive 5, so it will move to the right 5 places. Okay? Let's say I have another example. Let's say I have x plus 6. This is actually x minus a negative 6, so it will move to the left 6 places here. You got to be very careful about h. Inside that parentheses, this negative that you see is going to throw things backwards. Okay? Alright, now if k is positive, it's just going to move up. If k is negative, it moves down. We don't have to worry about that because there's a positive sign in front of the k. So what you see is what you get with k. So the vertex, we talked about this at the beginning, is h comma k. We're going to have to use the vertex form and look this up and say, okay, what is the vertex? And we can actually look at the formula and say, this is the vertex. Alright, so what we have here is a parent graph, y equals x squared. And what we want to do is see what would happen if I changed things here. So, let me get my pen. If I were to add 2, this is a k, so that this would move up 2 places. If I were to subtract 2 on the k, I would actually go down 2. Oops. Let's fix that. Alright, here with a plus 2 inside the parentheses, this is actually going to go left 2. And remember, that's because there's an x minus h, so this is x minus a negative 2. Now remember, that negative 2 means I move to the left 2 places. Alright, and then last but not least, I have a negative 2 inside. That's going to be x minus a positive 2, which means I go right 2 places. Alright, so you can see how the change is made. Plus 2 went up 2. Minus 2 went down 2. Inside the parentheses, I moved left 2 or right 2, depending on what's inside the parentheses. Alright, so your pop quiz item for today is that one of my favorite movies is the movie Ever After. It's got Drew Barrymore in it. It's a version on the Cinderella movie. And because it's Valentine's Day coming up soon, I'll probably make my husband watch it because I love the movie Ever After, and we very rarely get to watch it. We're more of an action, like Avengers kind of people, but if I ask you my favorite movie, please be prepared to say Ever After. All right, so let's try this equation. First off, we have 3x minus 1 plus 4. Now I see this plus 4, and I think I'm going to be up 4 units. I see this negative 1. It's actually a negative positive 1, so I know I'm going to move right 1. And then I see this 3, so I know I should become more narrow. So I'm able to look at all this information and be able to say, okay, this is what's going to happen. We'll do the math to verify, though. So the vertex is going to be 1, 4. Remember, don't include the negative because the negative is a part of the equation. Okay, we know it should open up because A is positive. We know it should be more narrow because it's 3, which is greater than 1. We know it should move right 1. And we know it should go up 4. So take a minute, and I want you to put this equation in your table function exactly the way you see it. Now you're probably wondering, how should you set up your table? Where should you start? Now I always like to put the vertex in the very middle and then choose 3 points to the left and 3 points to the right. So I want you to do the same thing. Now that you know which x values to look for, go ahead and fill in your table and plot the points. All right, now we had to change the scale of the y-axis in order to get it all to fit on the graph. So the points you have here, and then all you need to do is connect them to make your parabola. And that is the parabola of 3x minus 1 squared plus 4. Alright, so what I'd like for you to do is pause and try this one from beginning to end. I want you to put it in the table, tell me the vertex, the transformations, and graph it. Alright, so based on the information, I know that the vertex is negative 2, 1. Be careful, remember this is x minus a negative 2, the original minus being a part of the equation. I know this is a positive 1, so it'll open up. It will not be more narrow, it will not be wider because it is a 1. I will move left 2 and up 1, so I am able to plot my points and then connect them. Oops, and maybe not do such a great job when I connect them, but I can connect them to make a parabola. So again, a little bit of a shaky hand there, but you guys get the general impression. Alright, so we have one last one that I want you to give a shot. Okay, be careful, there is a negative out front. Alright, so the vertex should be positive 5, positive 3. The reason for that is the negative that's in here in front of the x right here is a part of the original equation. Close my parentheses real quick. I should open down because the number in front of the parentheses is negative 1, so this should open down. I should go right 5 and up 3. Alright, so I'm going to put the vertex in the middle. So this would be 5, 3. So I would choose numbers below it and numbers above it. And type it into the table. Alright, and now we need to plot our points. So now that we have our points, we need to connect them. Oops, that side didn't come out as well. Let's see, try again. Well, not perfect, a little wobbly handed, but you get the idea. What we're doing here is we're making parabolas, okay? So obviously yours is going to be a little better than me dealing with the touch screen because you'll have a pencil. That is it for the transformations of quadratics. Basically, we have to look at it in vertex form and go, okay, this is what's happening to the parent function. So I expect you to be able to do this in class tomorrow, and I will see you guys later.